There are endless mysteries and breathtaking wonders hidden in the universe. Although the planets discovered by humans so far are only an insignificant part of the stars in the universe, there are still many amazing things within this limited known range. Among them, there is a beautiful pink planet, GJ504b, located about 5-7 light-years away from our solar system in the direction of Virgo. This exoplanet orbits a star named GJ504. As a giant main sequence star similar to the Sun, GJ504's physical properties are crucial to understanding the existence environment of GJ504b. The radius of GJ504 is about 1 that of the Sun. Its mass is about 36 times that of the Sun, 16 times. As a powerful light source and gravitational centre in the universe, stars provide indispensable light and heat for surrounding planets, profoundly shaping the evolution of planets. The nuclear fusion process inside them continuously releases huge amounts of energy. This energy radiation in the form of light and heat affects the surrounding space. In the field of exoplanet exploration, scientists use a variety of methods to discover and study these distant celestial bodies. Commonly used methods include the directional velocity method and the zero-day directional velocity method. The method is to determine the existence of planets by observing the periodic changes in the stellar spectrum caused by the gravitational pull of the exoplanet on the host star. This method relies on extremely fine analysis of the stellar spectrum. The light emitted by the star is processed by spectrometry to form a spectrum. It contains a wealth of information such as absorption lines and emission lines of various elements. When an exoplanet exerts a gravitational effect on the host star, the star will produce a slight wobble in its orbital plane, which will cause periodic changes in the spectral lines in the spectrum. By accurately measuring and analysing these subtle frequency changes, Doppler frequency allows scientists to infer the existence of planets and calculate basic parameters such as the planet's mass. The zero-day rule is based on observing the movement of exoplanets to their host star. Subtle changes in the luminosity of a star caused by occlusion. When a planet passes in front of a star, it briefly blocks part of the star's light, causing a brief and tiny drop in the star's brightness. Through continuous monitoring and precise analysis of this change in luminosity, not only can it be determined, the existence of planets can also estimate important information such as the size and orbital parameters of the planet. This method is particularly effective for discovering planets close to the host star, but it also requires high-precision photometric measurement equipment and long-term observation data accumulation. However, GJ504b, it was discovered by humans through a relatively rare direct imaging method. As the name suggests, it is a direct imaging observation of exoplanets. The main reasons why GJ504b can be discovered using this method are two key and mutually reinforcing factors. On the one hand, GJ504b has an average distance from its host star of about 4.3 AU. This distance is about 9 times the average distance between Jupiter and the Sun. Such a large distance significantly reduces the possibility of it being overwhelmed by the light of the host star. At a closer distance, planets are often obscured by the strong light of the host star, making observation and separation extremely difficult. However, the large distance between GJ504b and the host star makes it. It is relatively easy to distinguish from the light of the host star in optical observations, creating favourable space conditions for direct imaging. On the other hand, GJ504b is a relatively young planet, with an age of only about 1.6 billion years during the planet's journey. In the early stage, it still retains a large amount of heat contained at the beginning of the stroke. This retention of heat makes its surface temperature as high as about 544 K and can release strong thermal radiation. This strong thermal radiation feature is very obvious in observations, making it higher brightness and observability in the infrared band. For astronomical observation equipment, this strong thermal radiation signal is easier to capture and identify, helps us to directly image and observe it. Through in-depth observation and precise study of GG504b, we have obtained a series of crucial data and information about it. This is a planet with a much higher density than Jupiter. The mass of the gas giant planet is about 4 times that of Jupiter, but its volume is similar to Jupiter. Its radius is about 0.96 times that of Jupiter. This unique density difference has triggered scientists to think deeply about its formation and evolution. Scientists believe that the formation of high density may originate from the complex gravitational contraction process in the past. In the field of astrophysics, gravitational contraction is a common but extremely complex and subtle process. When a large amount of matter gradually gathers together under the influence of gravity, the internal pressure and temperature will continue to increase. During this process, the interaction between materials and the transfer of energy will lead to significant changes in the structure and properties of celestial bodies. For gas giant planets like GG504b, gravitational contraction not only leads to its high density characteristics, but may also be an important source of heat that causes high temperatures on its surface. It is worth mentioning that the gravitational contraction process of celestial bodies is accompanied by the release of energy. This energy is expressed in the form of heat and further affects the internal structure and thermodynamic state of the planet. In the early stages of gravitational contraction, the rapid collapse of matter will cause the internal temperature to rise sharply, triggering a series of physical and chemical processes. As the contraction progresses, the material distribution and density structure inside the planet will gradually stabilize, but there will still be heat conduction and convection that affects the long-term evolution of the planet. For gas giant planets like GJ504b, understanding the gravitational contraction process is indispensable for revealing their formation and evolution mechanisms. Because GG504b, it was discovered through direct imaging. We can intuitively feel its unique and charming colour. It is extremely rare pink. However, there is no conclusive conclusion as to why GJ504b appears pink. This unsolved mystery inspired extensive discussions, and in-depth research in the scientific community have led scientists to speculate that pink visible light is a complex mixed light, which is formed by a variety of visible lights of different frequencies mixed with each other under specific physical and chemical conditions. Therefore, the pink appearance of GG504b, it should be the result of the synergistic effect of multiple factors. The surface temperature is undoubtedly a key influencing factor. Different temperatures will cause significant changes in the radiation characteristics of the material, thereby affecting the distribution of its visible spectrum. In high-temperature environments, materials may undergo specific changes. Spectral emissions produce light of specific wavelengths that contribute part of the colour to the formation of pink. For example, some substances may emit red light with longer wavelengths at high temperatures, which may be mixed with other wavelengths of light to contribute to the appearance of pink. Atmospheric components. It is also one of the important factors that affect the colour. The planet's atmosphere contains a variety of gases and forces. They have different absorption and scattering characteristics for light of different wavelengths. Some specific gas components such as methane, ammonia, etc., or tiny dust particles, it may selectively scatter or absorb light of certain wavelengths, thereby changing the overall colour appearance of the planet. For example, forces in the atmosphere may scatter shorter wavelength blue light, allowing more red and green light to pass through, thus affecting what we observe. The colour optical scattering process also plays a non-negligible role in colour formation. Light will be scattered multiple times when passing through the planet's atmosphere and surface materials. This scattering effect will change the propagation direction and intensity distribution of the light. The scattering process may cause certain wavelengths of light tend to travel in specific directions, thus affecting the colours we observe from different angles. In addition, scattering may cause the intensity of light to weaken or increase, further changing the colour appearance of the planet. Reflected light and self-illumination may also have an impact on GG504. The colour of B has an important impact. During the reflection of light from the host star on the planet's surface, due to the characteristics of the surface material, specific wavelength selection may occur, thereby changing the colour of the reflected light. The internal luminescence of the planet itself, such as thermal radiation due to high temperature, may also occur. It may interact with reflected light to create the pink appearance we observe. For example, the high temperature inside the planet may cause the material to emit light of a specific wavelength that mixes with the reflected starlight to form a unique colour. In fact, for scientists of this beautiful pink planet, what is more concerning is its formation mechanism. The core question. According to the core attack theory that currently occupies a mainstream position in the field of astronomy, stars are formed from the gravitational collapse of the original nebula. In this grand and complex process, as the density and temperature of matter continue to increase, stars are first born in the central area of the nebula. The material in the core area is highly dense. The gravitational potential energy is quickly converted into thermal energy, triggering a nuclear cataclysmic reaction to form a stably luminous star. After that, the remaining material in the nebula will form a disk-like structure surrounding the newborn star, a circular planetary disk. This disk is filled with various gases, dust, and tiny solid particles are the cradle of planet formation. The formation process of gaseous planets in the protoplanetary disk can be briefly described as first solid materials gradually form a rock or ice core through mutual attraction. When it reaches a certain mass, which is generally believed to be about 10 Earth masses, its gravity 3.5 astronomical units, far exceeding the theoretical limit distance for the formation of gas giant planets. However, it actually exists there with a mass of about this phenomenon, which is 4 times that of Jupiter, forces scientists to re-examine and think carefully about the existing planet formation theory. Is it true that the core attack theory has some undiscovered limitations and shortcomings, or is it a problem with GG504b? There are other special mechanisms and conditions that have not yet been recognized during the formation process, or there are deviations in our understanding of the material distribution and evolution of the protoplanetary disk. In order to further explore the mystery of the formation of GJ504b, scientists need to comprehensively use multiple methods: advanced observation methods and complex theoretical models, high-resolution astronomical observation equipment such as large ground telescopes and space telescopes can provide more accurate physical parameters and spectral information of planets, helping us gain a deeper understanding of its atmospheric composition, temperature distribution, and chemical composition. Numerical simulations and theoretical calculations can help us reproduce the complex process of planet formation and explore the impact of different physical processes and initial conditions on planet formation. Through detailed comparison and analysis of observational data and theoretical simulation results, scientists are expected to gradually narrow down the possible. The scope of explanation is ultimately the true mechanism of the formation of GG504b. From a broader perspective, the study of GG504b is not only an in-depth exploration of a single planet, it is also important for our comprehensive understanding of the formation and evolution of planets in the entire universe. It has far-reaching and important significance. Different types of planets widely exist in the vast universe. Their formation mechanisms and physical properties may vary greatly due to differences in their environment and initial conditions. Through in-depth study of special cases like GJ504b, we can significantly expand our understanding of the diversity of planet formation, enrich and improve the existing theoretical framework of planet formation, which will also help us in future exoplanet detection. More accurate identification and understanding of different types of planets will provide more favourable theoretical support and observational guidance for the search for planets that may contain life. For example, for those planetary systems with similar characteristics to branch 504b, we can, based on the understanding of their formation mechanisms, research, optimization of observation strategies and target selection, improve the probability of discovering potential colonizing planets. In addition, research on branch 504b can also effectively promote extensive interdisciplinary cooperation and in-depth exchanges in astronomy, physics, chemistry, and geology. Experts in the subject need to work closely together to study this challenging problem from different perspectives and methods. In the field of astronomy, astronomers need to rely on advanced observation equipment and superb technology to obtain more precise and detailed planetary observation data. Physicists can, using complex theoretical models and efficient calculation methods, to deeply explore the physical mechanisms and energy conversion processes during planet formation. Chemists can carefully study the chemical composition of the planet's atmosphere and surface, as well as the complex chemical reactions that may occur in order to understand the colour and atmosphere of the planet. Compositions and surface characteristics provide a solid chemical basis. Geologists can use analogies to geological processes on Earth to speculate on the structure and evolution of planetary interiors and possible geological activities. This interdisciplinary close cooperation can not only significantly accelerate the research on GJ50, the research process of 4B can also promote the cross-integration and joint development of different disciplines and effectively promote the overall progress of scientific research. For example, through interdisciplinary cooperation, we can develop a more comprehensive planet formation model that combines astronomical observations, physical theory, and chemical analysis. It is organically combined with geological speculation to provide a more comprehensive and in-depth understanding of the mystery of the formation of GJ504b. At the same time, the research on GJ504b has also greatly stimulated the public's strong interest and strong enthusiasm for space exploration. This mysterious pink planet has attracted people's attention with its unique charm, drawing more people to the forefront of space exploration. Public attention and support are crucial to the continued development of scientific research. It can provide more opportunities for scientific research. Resources and financial support promote the widespread popularization and in-depth development of science education and cultivate more young people interested in science to devote themselves to scientific research. For example, public attention to GJ504b may prompt the government and enterprises to increase investment in astronomical research, support the construction of more advanced observation equipment and carry out more detection missions. At the same time, this attention can also inspire schools and educational institutions to strengthen their emphasis on astronomy and science courses, cultivate students' scientific literacy and exploration spirit, and reserve talents for future scientific research in the future. In our research, we are fully expecting to be able to unravel the mystery of the formation of GJ504b and reveal more profound mysteries about the formation and evolution of planets in the universe. This will not only be a major breakthrough in the field of astronomy, but also provide human understanding of the universe. The understanding and exploration of GG504b and other exoplanets has opened a new chapter. With the continuous advancement of technology and the continuous deepening of research, we have every reason to believe that there will be more amazing discoveries and in-depth understanding of GG504b and other exoplanets in the future. Observation equipment and detection methods will allow us to observe these distant celestial objects more clearly and obtain richer and more precise information. For example, the new generation of space telescopes that are about to be put into use, such as the James Webb Space Telescope, have higher resolution and sensitivity, being able to detect weaker light signals and finer celestial structures. Through these advanced equipment, we are expected to obtain more detailed spectral information of GG504b to more accurately determine its atmospheric composition and chemical composition, and further reveal its colour. At the same time, with the continuous improvement of computing power, we can build more complex and accurate numerical models to simulate the entire process of planet formation. These models will be able to consider more physical processes and changes in initial conditions to reproduce planets more realistically. In addition to observation and theoretical research on the formation and evolution history of GG54b, there may be more space missions in the future to directly detect GG54b at close range. By launching a specialized detector to fly to this planet, we can obtain more direct and comprehensive information, Earth observation data, including key information on its magnetic field, gravity field, atmosphere structure, etc., provide us with more valuable clues to understand its formation and evolution. In the process of studying GG54b, we will also continue to improve and perfect the existing planets.